Hello, everyone. Can you hear me?
Yes.
Yeah.
Great.
Yeah.
All right, let's start. So again, please turn on your camera and so if you know how to present your name, like your name on the screen, please do it. All right, so today let's continue to talk about the exponents. So can you see the screen?
Yeah.
All right, great. So last time we discussed some properties for the exponents. So first we learned what is a power. So if something is denoted by a to the bth exponent, then here it's a power. So here a is the base and b is the exponent. And we know that if, so the first property says, so a to the nth times a to the nth equals a to the n plus n, right? So if you multiply two powers with the same basis, then you can just add the two exponents together. The second property says a to the m divided by a to the n equals a to the m minus n. Right? So if this is a division, then that's equivalent to subtract the exponents. So the third property says, so a to the m to the n, right? So basically, that means you take the exponents twice, right? And then that's equal to a to the m times n, right? So in this case, we just multiply the two exponents together. All right, so let's just do the problem 2.19 to review the three properties. So you see in the 2.19a, so basically we like to calculate like the result of this expression. And then you can see that definitely we need to calculate 2 to the 7th times 2 to the 8th first, right? So in this case, because they have the same basis, right? So both of the bases are 2. So basically we just apply the first property. So that's equal to 2 to the 7 plus 8, which is 2 to the 15. And then the next step is to calculate. So now we know that the parentheses equals 2 to the 15, then divided by 2 to the third. So in this case, we can apply the second property, right? Because they have the same basis. And then in this case, we just subtract the exponents. So we have 2 to the 15th minus 3. So eventually we have 2 to the 12th, right? So that's the result. And actually, we're supposed to calculate this number, right? So notice that I think you can try it yourself, but here, let me write down the answer. So notice that 2 to the 10th, it's recommended to memorize this like this result. So 2 to the 10th is 1024. Right? So 2 to the 12th will be 4 times 2 to the 10th. So that will be 4096. Right? So that's the answer. Right, so then let's do the second one. So in this case, again, we need to calculate the term in the parentheses first, right? So because that's an exponent. And in this case, because we need to, so that's equivalent to multiply the two exponents. So that will be 2 to the 6 times 4 divided by 2 to the 7. So here we'll have 2 to the 24th divided by 2 to the 7th. So eventually we have 2 to the 17th. Right? So that's the result for the second question. And for the third one, all right, so the third one is interesting because the two terms do not have the same basis. Right? You see that in the first term, the basis is 4, but in the second term, the basis is 8, right? So they are different. So is there any way to transform them into the same basis? So anyone has an idea? All right.
I think you just do like the 8. You can just make it like 8 equals 4 times 2.
Okay, so 8 is 4 times 2.
And then what you can do 8 equals 2 to the 3rd, and then the 4 to equals 2 to the 2nd.
Okay, good. So we can rewrite 8 as 2 to the 3rd and rewrite 4 as 2 squared, right? So then let's rewrite the whole expression. So we will have 2 squared to the 6th divided by 2 to the 3rd to the 2nd, or say square. So basically we just rewrite the two bases. We just rewrite 2 and 8 as a power of 2. Right, so question?
So can I do the next step?
Oh, sure, go ahead.
As you wrote there,
Mhm.
you can for the first 2 to the power of 2 and then 2 to the power of 6, it's just 2 to the power of 2 times 6, which is just 2 to the power of 12, and then divided by 2 to the power of 6,
Oh, good.
or 3 times 2.
Yep, so basically we just apply the third property again for the two terms. Right?
Yeah, and then you just do 2 to the power of 12 minus 6 because there's a divided sign, and then it's just 2 to the power of 6.
All right, so in the next step, we just apply the property 2 again. So basically, so that's equivalent to subtract the two exponents. So eventually we will obtain 2 to the 6th. So the answer will be 64. All right, so then let's look at the next question, 2.20. So express 11 to the 20,000th as 10,000th power by using the property. So basically we want to change the basis. Change the base. So this case, we want to find a base A such that A to the 10,000th equals 11 to the 20,000th. So again, we can apply
so since it's A by the I think it's 10,000 power, since 11 by the 20,000, so you can just do simply 20,000 divided by 10,000, which is equals 2. So then so then it equals 2 times 11, so then it's 22 by the 10,000th power. So A equals 22.
Okay, let's see if this is true or not, right? So basically we want to rewrite the exponent 20,000, right? So we want to rewrite it as 2 times 10,000. So in this case, if you rewrite the whole expression, you will get, so basically you get not 2. So 11 to the 2 times 10,000. So here, should we multiply 11 by 2? Actually, I don't think so, because here we should apply the third property to simplify it, right? So you see, in this case, the exponent is the product of m and n in this case. So that means you just set m to be 2 and n to be 10,000. So this is equal to 11 squared to the 10,000, right? So this is how you apply the property number 3. Then in this case, we do not multiply the 11 by 2. Instead, we will square the base 11. So basically, you get the number 121. So that's the answer. Right, so any questions so far? All right, guys, please turn on your camera. All right. So by the way, before answering the questions, please let me know your name. Okay. Okay, so let's go move on to the next one. So express 5 to the 30,000th as 10,000th power. So in this case, we won't do the same thing, right? So because in this case, we can rewrite 30,000 as the product of 3 and 10,000, right? And then we want to apply this property again. So what will be the basis? What will be the base in this case? So anyone want to answer the question?
Can Andrew do it?
Okay, Andrew, go ahead. Andrew?
Okay, so 30,000 equals 3 times 10,000. So you take the original number, which is 5, and then you have to cube it because you have to convert that into a power of 10,000.
Oh, very good. So basically, if we just repeat the same process, we have 5/3, or say 5 cubed to the 10,000th. So basically, we just need to calculate
125 to the 10,000.
Very good. So that will be 125. Very good. So then let's look at C. So in this case, we like to express so in this case, the base is 2, the exponent is 70,000. So what will be the base in this case? So anyone? All right, so because this is pretty similar to the previous cases, so let me do it. So because that's easy. I'll do the easy cases, so you guys will do the hard cases. All right, so because 70,000 equals 7 times 10,000, right? So in this case, so the base will be 2 to the 7, right? So that's equal to 128. Right? So basically, this number equals 128 to the 10,000th. Right? So that's the number. Then let's look at the next question. So in this case, we like to order the 3 number. So even though it only asks to find the greatest one, so I like you guys to order the 3 numbers from the largest to the smallest. So in this case, it's hard to do it directly, right? Because all of the bases are different and all of the exponents are different. So let's see. So A1, So, all right, so usually if you want to compare the three numbers, so you can either make them into the same base or the same exponents. So so for example, if you have 2 to the third, 2 to the fourth, and 2 to the fifth, then that will be very easy to compare them, right? Because definitely if the exponent is greater, then the number will be greater. Or if they have the same exponents, like 2 to the fifth, 3 to the fifth, and 4 to the fifth. So definitely, you know that 2 to the fifth is less than 3 to the fifth, and 3 to the fifth is less than 4 to the fifth. Question, Victor?
No, it's not a question. So, can I do that problem?
Oh, okay. Yeah. So,
Okay. So, you can also like make the exponents the same, and that would be really easy also because so you can compare them, and for each of them, like for the 11 to the power of 20,000, you can do it to 11 to the power of 2 times 10,000. Yeah, and then so 11 to the power of 2, that's, you can put that in parentheses and then times 10,000, and then you just do 11 to the power of 2, right? And that would
yeah.
just be 120. I mean 121.
Yes.
And then 5 to the power of 30,000 is just equal to 5 to the power of 3 times 10,000, and then that would also just be 125 to the power of 10,000. Yeah, and so far, by the way, the 5 to the power of 30,000 is the biggest, and so finally 2 to the power of 70,000 is just like 2 to the power of 7 times 10,000, and 2 to the power of 7 times 10,000 would just be 128 to the power of 10,000, and so the 2 to the power of 70,000 is the greatest.
All right, great. So basically, we can transform all of the three numbers into the same exponents. And actually, we did them in the question A, B, C, respectively. So in this case, we don't need to evaluate all of them because they are too large to evaluate. But we only need to compare the bases, right? So definitely 121 is less than 125 and less than 128. So that's why the last number is the greatest, right? All right, so any questions so far? So whenever you see a question to compare some numbers, the first thing is to consider the number line. Right? So if a number is to the right to another number, so definitely it's greater. Right? But if it involves like exponents or power, so you cannot mix them together. I mean, you have to keep one thing to be the same. Either they have the same exponents or they have the same bases. Right? Then you can compare, if they have the same exponents, then you can compare the bases. If they have the same base, then you can compare the exponents. Right? So that's the idea for this kind of questions. All right, so then let's go to the next section. So this time we will start the section 2.3. So in this time, we'll generalize the definition of the exponents, or say the power. So in the section 2.1 and 2.2, we only defined something like a to the mth. So where m is a positive integer. And so the definition is natural. So basically, it's just another way to express the product of the same numbers. And here, the number m, or say the exponent m, is the times. But what if, so can we generalize it to a zero exponent or a negative exponent? So we cannot do it by the original definition directly. So instead, we'll generalize it by using some properties. So let's look at the problem 2.22. So let m and n be positive integers. In the last section, we introduced the quotient of powers, right? So this is the property 2 we just discussed. So in this case, we can set m and n to be equal, right? So for example, we can set both of m and n to be 2 or 3 or 4. So definitely they make sense. If so, what will be the right-hand side, right? So for example, if m equals n, then 2 to the nth divided by 2 to the nth will be 2 to the nth divided by 2 to the nth itself. So definitely this is equal to 1. So here just, it's trivial, but let me point that out. So you know that this number is non-zero. So definitely, so that's why this makes sense. Right? So because any number divided by itself must be equal to 1. Right? So no matter this number is 2 to the m, or 3 to the m, or 10 to the m, or negative 1 to the m. Right? So no matter what the base is, so this number always equals 1. But there is an exception. So the base cannot be 0. Right? So the base, if the base is 0, we cannot get this conclusion by using this property because 0 cannot be divided. However, we can just supply a definition. So that's what we will do next. So here, we just add additional definition for the 0 exponent. So let a be a number. So then we just define a to the 0 exponent to be positive 1. So this is derived from the what we observed in the problem 2.22. Right? So whenever, if the exponent equals 0, then we can define the 0 exponent to be positive 1. And then let me make up another definition. So 0 to the 0th exponent is defined to be 1. So if the base is 0, then if both of the base and the exponent are equal to 0, then it's defined to be 1. So because this cannot be derived by the property directly, because 0 cannot be, or say 0 cannot be the denominator. But we can define it to be 0. Oh, sorry, we can define it to be 1. All right, so that means, so for example, if you have 3 to the 0s, so it must be 1. If you have 10 to the 0s, it must be 1. If you have negative 2 to the 0s, then it must be 1. So whenever you see the 0 exponent, it is equal to a positive 1. All right, so then let's look at the next problem, 2.23. So evaluate the simple expression. So here we just need to apply the definition of the exponents to evaluate the 3 terms. Right. So let me do this easy case. So the first term is equal to 1. The second case is second term is 6, and the third one is 36. So then we just need to add them together. So the sum will be 43. Right, so then let's look at 2.24. So let a be any number, then simplify the expression. So anyone has an idea for 2.24? All right.
I'm William.
Oh, William. Okay, go ahead.
Can I do it?
William will do it. Go ahead.
So you first
For a in the zeros,
Mhm.
so you can simplify it by in the order of operations, you first do a to the 0.
Good. So then what will be a to the zeros?
It's 1.
It's 1. Good. So let me just copy the 4 here. Then the next term is 1.
And then you multiply 4 times a, which is like a number, and then in the like 1 times 0, and
Mhm.
it's in the of 0, so it's 1.
So this will be another 1, right?
Yeah,
So the answer is
4.
the answer is 4. Very good. So by the way, so actually we should calculate the parentheses first. Right? So whenever you see a parentheses, so it's always prior to all of the other terms. But in this case it doesn't matter because they are like it doesn't affect the answer. So in this case, but in all of the other problems, please take care of that. Right? So in this case, if we calculate 4a parentheses to the 0 exponent, so that will be 1, right? Because we don't care what the basis is. Whenever you see the 0 exponent, it is 1. Then, so let's calculate 4 times a to the zeros, because we need to calculate a to the zeros first, right? Because that's a power. So that's 1. Then we multiply it by 4. So that's why the answer is 4 instead of 1 in this case. Then 25. So any idea? So let P be a number and Q be another number. So what's the value of 2 plus 3 plus 4 plus 7 to the P plus Q? So to begin with, let's try if we can figure out something. Right? So let's see, at least, so those three numbers are easy to calculate. Right? So let's find them out. So P is, so what is the base for P? So that's easy, right? So that will be 2. So 2 minus 3 minus 4 plus 7, so that's 2. Right? 2 to the 2, 3, 4, 7. Right? So that's P. Then Q is negative 2, right? Q is negative 2 to the 2, 3, 4, 7. All right. So what will be P plus Q?
P plus Q is 0 because you're adding like a
I cannot hear you. So anyone?
P plus Q is
Please.
0. You know why? Because since the exponent is odd for the Q,
Mm-hmm.
the product, whatever it is still negative, and yeah, and you don't really want to figure that out because you just like, because those two cancel out with each other, P and Q, so it's actually just 0 and the whole thing is just 1.
Okay, so let me just write down one more step. So basically, because you see, so the second base is the negation of the first base. So I like to write it as negative 1 times 2 to the 2, 3, 4, 7. Right? So in this case, we can rewrite it as negative 1 to the 2, 3, 4, 7 times 2 to the 2, 3, 4, 7. So in this case, because this is easy to calculate, right? Because if the base is negative 1, then when the exponent is odd, then that's equal to negative 1. When the exponent is even, then it's equal to positive 1. So basically, that's equal to negative 2 to the 2, 3, 4, 7. So that's why their sum equals 0, right? Because Q is the negation of P. So their sum equals 0, then you can easily calculate the final answer, right? So the final answer is 16 to the zeros. Right? So that will be 1. Actually, you don't even calculate the base, right? Because whenever you know the exponent equals 0, then the answer must be 1. All right, so then let's move to the next section. So because the 0 exponent is too special, right? So you just need to memorize this property. Then we can generalize the exponents further, right? So the exponent can not only be 0, they can be negative as well, right? So again, we want to apply this property further to investigate what happens if the exponent is negative. So in this case, if m is less than n, then m minus n will be negative. Right? So then, so that means the exponent will be, so in this case, so this is another way to define 3 to the negative 2. So in this case, you can try the following one. So for example, you just set m to be 1 and n to be 3, right? So then you have m minus n equals negative 2. Or you can just set m to be 0 and n to be 2. Then this is another way to get m minus n to be negative 2. Right? So you can use either of them. Right? So let me use the second one. So if I use the second one, then 3 to the negative 2 equals 3 to the zeros divided by 3 squared. So basically you have 1 over 3 squared. So that's equal to 1 over 9. Right? So this is how to derive it by using the property. Then let's look at the formal definition. So it's given here. And actually that's exactly what we did. Because in this case, you just set m to be 0 and n to be n. Then there you will have a to the zeros divided by a to the n. So that's why the numerator equals positive 1. Okay. So that's why a to the negative n equals 1 over a to the n. Okay. So this is how we obtain this definition. Oh, so any questions so far? No? All right. Then, so anyone wants to do 2.28. So in this case, we just want to practice the definition. So anyone? Or if you just want to do one of them, that's fine. So anyone wants to 28, 1?
Okay.
Oh, okay, go ahead.
For problem 2.28, the first one is 1 by the power of negative 5. So then it's
Oh, can you turn on your camera?
and then it's 1.
Oh, it's
No,
1.
1 over 1 by the power of 5, which equals 1 over 1 times 1 times 1 5 times, which equals 1.
Oh, good. So that's equals 1, right? All right, so how about the second? So anyone wants to do the second one?
Andrew do it?
Okay, Andrew, go ahead.
So 10 to the negative 4th, we can convert that into 10 to the 4th because the negative 10s cancel out or multiply to become regular. So 10 to the 4th is 1 with 4 zeros.
But in this case, the negative sign is on the exponent. It's not, the base is not negative 10. Right, so if you recall the definition above, when the exponent is negative, we just take the reciprocal. Right? So in this,
So it's 1/10,000.
oh, good. So that will be 1/10 to the fourth, right? So that's 1/10,000. All right. How about the third one? So anyone wants to do it? Okay, go ahead.
So it's just 1 to the second. I mean 1/2. Well, the bottom one, the 2 is 1/2 to the third, which is 1/8.
Okay, so that will be 1/8. All right, so how about number 4? Wait, let me see how to see the name. Do you know how to show your name on the...
Maybe you have to do the split screen. You have to split your screen by dragging one tab by pressing the restore down button, then pushing it to the side of your screen.
Oh, you mean I'll do it or you will do it?
No, you.
Oh, anyway.
Can I do number 4?
Yes, number 4.
So number 4 is basically just 56 times 2 to the negative third power, which is 56 times 1/8. And then
Okay.
56 times 1/8 is equal to 7.
Good, so the answer is 7. So let me just write down one more step. So because 2 to the negative third equals 1 of the reciprocal of 2 cubed, right? So that will be 56 times 1/8. So the answer is 7. Good, so the last one. So anyone wants to do the number 5?
Can I do it?
Oh, sure.
So basically number 5 is you do 56 divided by 1/8 because of the negative,
Mm-hmm.
and then your answer is
So
which is basically 56 times 8.
very good. So that's equal to 56 times 8. So what is the answer?
Um
Oh, that's fine because I think that's 448, right? Is that 448? Right, yeah, I think so. So if you have different opinion, please let me know. All right, so actually in this case, I think that it's, you guys can always calculate the product by yourself, right? So the point is how to like transform the negative exponents into what you know, right? So like how to transform the division about 15/6 and the 2 to the negative 3 into 56 times 8, right? So that's important, or say that's the most important step in these cases. Then 29. So please compute the followings. Again, there are 4. So there are another 4 examples. So anyone wants to do? So let me divide it into 2 parts. So anyone wants to do the first and second? Okay.
Drew?
Can I do one? Can I do one?
You have to do
Only?
1 and 2, both. Let me see. Jacob,
Okay.
can you do number 1 and number 2?
Okay, so the first one is 3 to the 5th times 1/3 to the 5th, which is basically 1 because they like cancel each other. And then and then 2
Mm-hmm.
is 3 to the 6th times 1 to the 1 over 3 to the 4th, which is 1 over 81, and then and then you just times that, which is 36 over 81, and it can be simplified as 4 over 9.
Well, so in this case, the first term, are you sure it's 36? So basically, you should multiply 3 6 times. Okay, so
Yeah.
that's 3 times 3 times 3 times 3 times 3 times 3. So you see 3 times, so if you multiply 3 times, that's 27. So this is 27 times another 27. So it's not 36, right? Because it must be much greater than 36. So actually, you don't have to calculate 3 to the 6th, right? Because there is another property we can use. So basically, if they have the same basis, you can always apply the property, right? So you can always add the two exponents together. So you have 3 squared, right? Because 4 plus -4 equals +2. So the answer is 9. Or you can definitely use the definition. I mean, from here, you will have 3 to the 6th over 3 to the 4th. And then you can just write it as, so here, let me show how to cancel them, right? So if I use the definition of the exponents, so you'll see that they are canceled, 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 and canceled. Okay. So that's why, so there is a 3 squared left in the numerator. So that's why the answer is +9. Right. Anyway, so that's good. And anyone wants to do the number 3 and number 4?
Can Andrew do it?
Andrew?
Yeah.
Okay, go ahead.
Okay, so number 3 is 3 to the -1 times 3 to the -2. Okay, so we can first simplify the power to the negative exponent to 1 over 3 over 1, or 1 over 3, and multiplied by 1 over 9, or 3 squared.
Good. So 9 is 3 squared.
So
Then
that's
the answer is,
that's 1 over 36.
are you sure? So that'll be 1 over 3 times 9, right? So
Oh,
what is 3 times 9?
Wait, isn't like 12 over 36, or 1/3?
What is that?
That's 1 over 27.
Good. So that's 1 over 27. So how about last one? So the number 4 is a product of 4 powers, right? So all of them are power 4. So what is it? Anyone wants to do number 4? Okay, Victor, go ahead.
Okay, so we're just gonna leave 3 to the power 15 first because we'll just see if we have any luck with anything else. So first 3 to the power of -5, it's just basically 1 over 3 to the power of 5. Yeah, 1 over 3 to the power of 5, and then times 1 over 3 to the power of 4.
Okay.
and then times 1 over 3 to the power of 3.
Okay, and then
Yeah, and then so
well, so in this case, you can multiply the three fractions together first.
well, yeah, so that'll just be 1 over 3 to the power 5 times 3 to the power 4 times 3 to the power of 3. Yeah, and then what you do is 3 to the power of 5 plus 4 plus 3.
So that's equal to,
And that's equal to 1 over 3 to the power of 12.
okay, good.
And then that's
So-
basically, and then the end result is just 3 to the power of 3.
Good. So because they are canceled, so we'll have 3 cubed. So basically that's 27. All right, so good. So in this case, there are two ways to do that. So first, you can apply the definition of negative exponents. So just like what Victor did. So you just transform all of the exponents into fractions and then multiply them together. Or you can use the property directly. So basically, because they have the same basis, so that's equal to 3 to the 15 plus -5 plus -4 plus -3. So you can still add all of the exponents together because this is a property. It's true for all of the exponents. I mean, whenever they have the same basis, you can always apply this property. Then you just need to calculate the exponent, which is 3. So eventually you get 23. Right? So this is another way to do it. So anyway, let's look at the next one, 2.30. So there are 3 questions. So let me do the first 2 very quick because they're easy. Oh, they're not, right? So anyone wants to do number 1 and number 2?
Can Andrew do it?
Oh, I'm sorry, who will do it?
Andrew?
Okay, Andrew, what's the number 1?
Okay, so number 1, we can also use the a to the negative power equals 1 over a to the right to b property to convert 1.
So what is that?
So 1 over 2 to the third.
All right, so can we still amplify it?
So that's 1 times 1 over 8, which is 1 over 8.
Is that 1 times 1 over 8?
Yeah.
So actually this means you take the reciprocal of 1 over 8, right? So what's the reciprocal of 1 over 8? It's 8, right? So that's equal to 8. Actually, you can think about it in this way. So whenever you take an reciprocal that's equivalent to raises to a -1 exponent. So I mean, -1 over a is always equal to a to the negative first. Right? So this is equivalent to for the negation. Right? So whenever you take the negation, that's equivalent to multiply it by -1. So whenever you take the reciprocal, that's equivalent to raise the -1 exponent. Right? So just keep this property in your mind. So if this is true, then let me just do it in this way. So that's equal to 2 to the -3 to the -1. Right? So I can write it in this form. Then you can multiply the 2 exponents together. So that will be 2 cubed, which is +8. well, so for number 2, we can do the same thing. Right? So anyone, so just tell me the answer. What is 1 over 5 to the negative 2, negative second?
25.
It's 25, good. So basically, you can either take the reciprocal twice. So that will be 1 over 25. So that will be 25, right? Or you can use the property there. So that's equal to 5 to the negative 2 to the negative 1. Right? Then this is equal to 5 to the negative 2 times negative 1, which is 5 squared. Right, so you can use anyone to calculate it. Right, so it's up to you. But the point is to get familiar with the properties of the exponents. I know it's confusing sometimes, so that's why you need to practice and get familiar with them. All right, so number 3. So let a be a non-zero number and n be a positive integer. So how are 1 over a to the negative nth and a to the nth related? So just like what we did, so 1 over a to the negative nth is always equal to a to the negative nth to the negative 1. So that's equal to this. So that's equivalent to multiply the two exponents together. So the exponent will be n eventually. So basically they are equal. Okay. All right, so then let's look at 31. So evaluate the following expressions. So anyone wants to do number 1. So what is 1/2 to the negative 1? And 1/2 to the negative 2 and 1/2 to the negative 3? Okay, so Victor.
So for 1, it's equal to
I cannot hear you.
so for 1, it's 1. So for 1, number 1, it's 1 over negative 3 to the power of 2.
Oh,
1
which
over
one? Are you talking about the 1/2 to the negative first?
wait, oh, so that one,
Uh-huh.
it's equal to like 1 over 1 over 2 to the power of 1 over 2. Yeah, and that's just equal to 2.
Okay, good. So that's 2. How about the second one?
So the second one is just 1 over 1 over 1 over 2 and then to the power of 2, like positive 2.
1 over 1 over 2. Is that what you? Okay.
Yeah, and then that would just be 4.
Okay, so that's 4. Then the
Yeah,
third
and the
one
last
is?
one would just be basically the pattern, and that would just be 8. So the
Okay,
last one is just 8.
good. So the last one is 8. Good. So, or you can use the one we learned in the previous problem. So basically, in this case, we can rewrite the base as an exponent. So that means you can write 1/2 as 2 to the negative first. Then, so 1/2 to the negative first equals 2 to the negative first to the negative first. Right? So in this case, we rewrite the base. So then you have 2 to the negative 1 times negative 1. Right? So that's 2 to the first, which is 2. So for the second, so that's equal to 2 to negative 1 to the negative 2. Again, you can multiply the two exponents together, so you have 2 squared. which is 4. Oh, sorry. For the last one, you can follow this pattern. So we have 2 to the negative first time to the negative third. So you have 2 cubed, which is positive 8. Right? So this is an alternative way to calculate this problem. And then let's look at the question B. I believe they are still equal, right? Just like what we did. And you can either apply the definition of the negative exponent to see if they're equal or not, or you can just apply the property. You can apply this method to check it. So basically, so that's equal to a to the negative first to negative n. So a to the negative 1 times negative n. So that's a to the n. So this is a way to check it. Right, so how about 3.32? So evaluate the following expressions. So anyone wants to do the first and second and third? Okay, what's William, okay, go ahead.
Okay, one negative three to the power of like negative 2.
Mm-hmm.
You can turn it to net 1 over negative 3 to the power of 2.
So in this case, what's the base? Is the base negative 3 or just 3?
Negative 3.
Are you sure?
No, 3.
So because in this case, there is no parentheses, right? So you should take the negation after the power, right? So yeah, so basically the base is positive 3, right? So this is the base. So this is the term you should calculate first, right? Because that's the power, right? So that's equal to 1 over 3 squared. Then take the negation. Okay, so what's the result?
It's 1 over 9.
Yep, so the fraction equals 1 over 9, right? So after taking the negation, that's negative 1 over 9.
Yeah.
Right, great. Then how about the second one? Can you do it?
Okay. The second one is
so it's a power, right?
Yeah. It's 1 over negative 3 to the power of 2.
Good. So it's 1 over negative 3 squared. Right?
Yeah.
Then can you calculate the denominator?
1 over 9.
It's 1 over 9, right?
Yeah.
Good. So the answer is 1 over 9. So in this case, because there is a parenthesis, so that means negative 3 is the basis instead of 3. All right, how can you continue to do number 3?
Okay. You can turn it into 1 over negative 2 cube.
Good. So that's 1 over negative 2 cube.
Which equals 1 over 8.
Is that 8 or negative 8? So this time you multiply negative 2 3 times.
Yeah, it's negative.
It's negative 8, right? Good. then what's the result in this case? So what's the answer?
Result is negative 1 over 8.
It's negative 1 over 8. Very good. All right, so anyone wants to do number 4 and number 5? Evie?
Well, I have a soccer game to get to, so I have to leave right now. Is that okay?
Oh, I'm sorry, can you say it again?
I have a soccer game right now.
You have what?
I have to go. I have a soccer game.
A soccer game?
Yeah, I have to go.
Oh, okay. Go ahead. Hi. So anyone wants to answer the question? Oh, anyone wants to do number 4 and number 5?
Can I do it? Andrew?
Okay, Andrew, go ahead.
Okay, so A, how are 2 to the negative third and 2 to the negative 1 to the third related? So, so in the parentheses of the second one to the negative first, that is basically the negation of 2, or you could transfer that
Oh, are
negation
you?
to exponent.
I'm sorry, which one are you talking about?
A. And problem 2.33. Oh,
Oh,
wait,
oh.
I have to talk. Oh, wait, I got mixed up.
Can you do number 4?
Yeah, okay, so 1 over negative third, the negative second power, you can use the property to make it 1 over negative 2 to the third power.
Oh, number 4. Number 4. This one. The base is
Wait,
negative
it's
3.
negative 3.
Yeah, it's negative 3. And then what is it?
1 over 3 to the negative second power.
Good. So 1 over 3 squared, right?
Yeah.
So what is it?
That's negative 3 squared.
Good. So negative 3 squared equals?
Negative 3 squared equals the negative 9.
Is that negative or positive?
Positive.
It's positive 9, right? So it's 1 over 9. So what's the final answer?
Positive.
I cannot hear you.
Positive 9.
It's positive 9. Good. So the answer is positive 9. How about number 5? Can you do it? Can you do another one?
Okay, so you do the same thing.
Mm-hmm.
1 over 2 to the third power, 2 cubed.
Mm-hmm.
And that's 1 over negative 6.
Are you sure that's negative 6? So you multiply negative 2 3 times.
Oh, it's positive 6.
Is that positive 6?
Oh, yeah, it's negative 6.
I mean, is the value equal 6?
The value is negative 6.
I mean, so if you do negative 2 times negative 2 times negative 2, what is it?
That's negative 6. Oh, wait, negative 12.
Oh, let's do it step by step. So it's 4 times negative 2, right? So that's negative 8. So in this case, it's 1 over negative 8. Then can you tell me the final answer?
Negative 8.
Negative 8, good. All right, so then let's look at 33. So let me do 33 very quick. Okay. So how are so basically you just need to evaluate the two numbers to see what's their relation. Right? So the first one is 1 over 8. So basically that's 1 over 2 cubed. So the second one is 1/2 cubed, which is 1 over 8 again, right? So they are equal. Then in the second one, so again, we can apply a property to check if they are equal or not, right? Because basically 2 to the negative first to the nth, so that's equal to 2 to the negative 1 times n, which is 2 to the negative nth, right? So you can always multiply the two exponents together, so they are equal. Then this time we would like to generalize it further. So we like to see if this is true for any basis A, for any non-zero base A. So we have, again, we just repeat this process. So that's equal to A to the negative 1 times n, which is A to the negative n. So again, they are equal. Right? So basically, that means, so if you want to take the negative exponent, that's equivalent to take the reciprocal first, then take a positive exponent. Okay, so they are the same thing. So that's what 2.23 wants to tell you. Then let's look at 2.34. So let A and B be non-zero numbers, then explain why the two sides are equal. So this is somehow similar to a distributive law. So basically you're distributing the exponent. Right. So we like to see if we can distribute the exponents to all of the terms. So then let's check the two sides. So AB to the negative 6. We know that this is equal to 1 over A times B to the 6. Right? And then for the denominator, we know that, so we have somehow a distributive law, so which means we can distribute the exponents when the exponents are positive. Right? Then, so we can write it as 1 over A to the 6 times 1 over B to the 6. So basically the first term equals A to the negative 6 times B to the negative 6. So this is how we show the two sides are equal. Basically, if the expression is abstract, or say there is no any number, there are just some variables or characters. So usually we start from something with the parentheses, because that means you can apply some rule or some properties to simplify it, or say to rewrite it. So that's why we prove it, we show it from the right side to the left side, right? Because if you start from the left side, it's not obvious what you can do. So at least when I see it at the first time, I prefer to start from the right side to the left, right? Because I know I can distribute the exponents, right, to see if the two sides are equal or not. I mean, this is something you can think about, or say, if you really take part in a contest, you can think about a problem in this way. Then 2.35. So express each of the terms as the power of 2. So this is pretty similar to what we did at the beginning of the class. Right? So in this case, we want to rewrite all of the bases as the exponent of 2. So we know that 4 equals 2 squared. And the negative 2, well, so this is no way to rewrite it, right? Because negative 2 is not equal to 2 to the any raised to any exponent, right? So no matter the exponent is positive or negative, it's always positive. The power is always positive. Right? So you have to see if there is any way to simplify this whole the expression. Then the third one, so 16 is equal to 2 to the fourth. Now we can start to rewrite the three terms. So the first term equals 2 squared to the 16th. So that's equal to 2 to the 2 times 16, which is 2 to the 32nd. Then for the second one, so negative 2 to the 34. So in this case, we have to apply the property of negative 1, right? Because the exponent is an even number. So this is equivalent to negative 1 to the 34 times 2 to the 34. Because this equals positive 1, so the answer is 2 to the 34. So even though negative 2 is not equal to a power of 2, but you can use the property of negative 1 to simplify it. Then for the third one, so 16 to the 8th. Right, so this is how we rewrite 16. Then we can multiply the exponents again. Right, so this is the last one. All right, so let's look at 35b. So for 35b, we like to apply the same idea. So basically, we want to rewrite the basis as a power of 2. Right, so 1 over 8 equals 2 to the negative 3. And for the second one, there's nothing to do because it's already a power of 2. So you can just copy 2 to the negative 4. All right, so let's rewrite the two terms. So that's equal to 2 to the negative 3 to the negative 11. So that's equal to 2 to the negative 3 times negative 11. Right. And to rewrite the next one, we just apply the property directly. Right, so we get 2 to the 32. Excuse. All right, so then the question C, order the 5 numbers in A and B from the large to small. So can anyone do it? So in this case, we get 5 powers of 2. So can you range from large to small? So anyone wants to do it? So because they have the same base, so that's why we only need to compare the exponents. So anyone? So what is the largest one in this case? What is the, yes, William.
The largest one is 2 on the power of 34.
Good, so this is the largest one. So basically negative 2 to the 34 is the largest one. Then what's the next?
The next is 2 to the 33.
Good, so 2 to the 33 is the next. So the next one will be 1 over 8 to the negative 11. How about the next?
The next one is 2 power of -4, -8.
So
It's
the
2.
Go ahead.
It's 2 to the power of 32.
Good. So the next one is 2 to the power 32. So actually all of the others are 2 to the power 32, right? So they are equal and they are the smallest, right?
Yeah.
So you can write it as 2 to the -4 to the -8 equals 4 to the 16th equals 16 to the 8th. So all of the three numbers are equal. So their order does not matter, right? So you can either write 4 to the 16th to be the first, or 16 to the 8th to be the first. Great. Then let's look at 36. So let x and y be non-zero numbers. So simplify the product.
Can I do it?
Oh, sure. Victor, go ahead.
So it's x to the power of 4 times y to the power of -2. Put that in parentheses, and then times parentheses x to the power of -1 times y to the power of 5, and that's also in parentheses. So what we can do is use the commutative and associative properties to like put the x's and y's together. So that would just be x to the parentheses x to the power of 4 times x to the power of -1, and then times parentheses y to the power of -2. Yeah, and then times y to the power of 5.
Okay, so
And
what's the
then
next?
now basically we do x to the power of 4 plus -1, which is basically x to the power of 3.
Good. And
then times y to the power times y to the power of just 3, y to the power of 3.
Oh, good. So that's the answer, right?
Yeah, because you don't know what x and y are, so you can only simplify it.
Yeah. Oh, great. So in this case, x and y are variables. You can consider them as variables, so you don't need to specify their values. Anyway, so yeah, so this is the answer. So basically, this process is called combining like terms, right? So basically, x and x, they are like terms, and y and y are like terms. Right? So you multiply the two x terms together and multiply the two y terms together, and then simplify the exponents. Good. So then let's go to the challenging problems.
The challenging problem 6.2.62 is 2 by the power of 2 times 4 by the power of 4 times 8 by the power of 8 times 16 by the power of 2, and then all the way times to the until it goes to 1024 by the power of 2. So this is what I thought. I thought that it wouldn't like take a lot of numbers to get to 1024. So then I just did 2 by the power of 2 times 4 by the power of 2 times 8 by the power of 2 times 16 by the power of 2 times 32 by the power of 2 times 64 times the power by the power of 2 times 128 by the power of 2 times 256 by the power of 2 times 512 by the power of 2 times 1,000, and then
So you just list all of the numbers there, right?
yeah, so then it's like I just did. So then it equals 2 by the power of 2 times 2 times 2 by the power of 2, 2 times 4 by the power of 2, and then so then I was just making every single number like 2 times something, so then it's easier. And then I got
So can you tell me one by one? So how will we write the first term?
I wrote out all like like the values, so like 2 by the power of 2 all the way to 2024. By the power of 2, I wrote all the numbers out in between, which aren't really like a lot. So it's 8 by the power of 2 times 16 by the power of 2.
Oh, yeah,
And
yeah, I know that because eventually you have to express the whole thing as a power of 2, right? So you can
so then,
express every term as a power of 2. So
yeah,
how
so then that's what I was gonna do. And then it equals like 2 by the power of 10 times 2 times 2 times 2 by the power of 3 times 2 by the power of 4 times 2 by the power of 5 that times 2 by the power of 6 times 2 by the power of 7 times 2 by the power of 8 times 2 by the power of 9 and then that all times together and then by the power of
can
2.
you tell me can you say it one by one? So how you rewrite, for example, how we write 4 squared? So what is that?
2 times 2 squared equals
2 times 2.
yeah, and then squared.
So 2 times 2 squared, that's equal to 2. What's the
Well, and
exponent?
wait, what? Can you say it again?
So how we write 2 squared as a power of 2? So what's the exponent in this in 4 squared?
2.
2? Are you sure?
Well, it's 2 by the power of 2 in parentheses, and then by the power of 2.
Yeah, so that's equal to 2 raises 2. So what's the exponent there?
2 by the power of 4.
Good, so that's 2 by the power of 4. So actually you can do this for every term, right? So you just rewrite the first term as 2 squared, the next term as 2 to the 4th. And
I did all that stuff, which is like, it took like a whole page of the notebook. So it's really
really?
long. So I don't
Okay.
want to say anything, but my answer is 2 by the power of 108. No, it's 2 by the power of 54 times 2, which is 2 by the power of 108.
All right, so let's
And
check if this is true or not. So, yep. So basically, let's just like what you said. So actually, let me just write them down step by step. Okay. So first, we can rewrite every term as a power of 2. Right? So we can list all of them. So the last term is 2 to the 20th, right? Because 1024 is 2 to the 10th. So 1024 is 2 to the 10th squared, so that will be 2 to the 20th. So in this case, we can apply the property to add all of the exponents together. So we have 2 plus 4 plus 6 plus 8 and so on, and plus 20. So basically, you only need to calculate the exponent in this case. So that means you only need to calculate the sum from 2 to 20. So what's the sum there? So we know that we can calculate it by a formula. So that's equal to 2 plus 20 times the number of the numbers there. So how many numbers there? Or say how many terms in the product? So again, we can apply the formula to calculate it. So we have 20 minus 2 over 2 plus 1. So there are 10 terms. Okay, so we multiply the whole thing by 10, then divide it by 2. So eventually, this is equal to 110. So that means the answer is equal to 2 to the 110. All right, so I believe this is the answer. Yep, so it's very close, right? So I think you just missed a number somewhere or made a mistake somewhere. But anyway, it's pretty good. So any questions so far? So the point here is to rewrite every term as a power of 2, right? So then you can apply the property to simplify it. Then how about 2.69? So anyone wants to do it? Oh, because we only have 6 minutes, so let me do it. So let me do the rest of the questions. So basically we know that 6 equals 2 times 3, right? So 6 to the 6 exponent power equals 2 to the 6 times 3 to the 6, right? So that means you are looking for a number n such that n times 3 to the 4th times 2 to the 5th equals 2 to the 6th times 3 to the 6th. So basically you just need to compare the two sides, or you can divide the two sides by this number. So n equals the right hand side over right? So the right hand side divided by 2 to the 5th times 3 to the 4th. So basically you divide both sides by this number, then you can calculate n, right? So this is how it's solved for the equation. Then this is equal to, so we can easily cancel them. So 1 left and 2 left, right? So that will be 1 to the 1st times 3 squared over 1. So the answer will be 18. So this is how we calculate n in this case. But the crucial step is to rewrite the number 6, as a power of 3 and 2, because 3 and 2 are in the left-hand side. Okay, so that's why we do it. Then 2.68, so let A, B be numbers and simplify the following expressions. So this is pretty similar to an example above, right, to 2.36. So we still want to apply the same process to calculate it. So we have, so if you simplify A, so that will be 2 cubed times A cubed times B squared cubed. So basically we can distribute the power, the exponent to all of the terms in the parentheses. Right? So we have 8 times A squared times B to the 6. Right? So that's one way to do it. Or you can apply the definition. Right? You can multiply the 3 terms, the same term 3 times to calculate the product. For the second, so again, let's calculate the power first. Then that will be 5a squared b times 8a cubed times b cubed, right? So in the second parentheses, that's the third power of 2ab. Right? Then we multiply them together. So we have 40 times a to the 5th times b to the 4th. Right? So that's the answer. The same here, we multiply the two numbers together, so we get 40. Then we multiply the two a terms together, so we have a to the 5th. Then we multiply the two b terms together, then we have b to the 4th. Right. Then the next one is 2.20. What is the large number n for which n to the 2000 is less than 5 to the 3000? So in this case, we still want to compare, because it's very hard to compare the base, right? So that's why we want to make the exponents to be equal, then compare the base, compare the bases. So how to do that? Because in this case, so we can rewrite the first term as n squared to 1,000 exponent. And then we rewrite the second number as 1 to 5 to 1,000 exponent, right? So this is what we can do. We can make the two exponents to be equal. Then we can compare the bases. We like to find the number n, the largest number n, for which n squared is less than 1 to 5. So n will be 11, right? So in this case, so 11 will be the largest. All right, so 71. By the way, so when we choose 1,000 there, because we want to reduce the calculation as more as possible. Okay? So we don't want to do so many calculations. So we want the exponent to be as large as possible. So you see 1,000 is a factor of both of 2,000 and 3,000. So that's why we choose 1,000 to be the exponent. Then 71, what's the value of x for the equation? So again, this is pretty similar to 65. Right? So 2.65. So basically, we still want we write 30 as product of 2, 3, 4, 5. Right? So we know that 30 equals 2 times 3 times 5. So that's why 30 cubed equals 2 cubed times 3 cubed times 5 cubed. Right? So then we just divide both sides by this number. So basically by this product to calculate 2 to the x. So 2 to the x will be equal to the quotient. Right, so then you can figure out the exponent x in this case. For 72, sorry about the extra minute. Let me just give me one more minute. For 72, you can just apply the distributive law to check the two sides. Actually, I hope you guys can memorize the three expressions. So memorize them because they are very useful. So it's very useful to know the expression for a plus b and a minus b squares, and a plus b and a minus b cubes, right? And a cubes minus b cubed, a cubed plus b cubed, and a squared minus b squared. But there's no expression for a squared plus b squared. So there is no expression for that. But in the future, so when you're like in a high school or in going to the college, so you will learn an expression for that, but it depends on something else. So it depends on the imaginary numbers. So that's another story. So at this moment, you just need to know that there's no expression for a squared plus b squared. Okay. All right, so for 2.76, so basically you want to know how many digits there. So first we know that this number consists all of the squares from 1 to 35. 35 squared. So 1225 is the square of 35. So basically, this is the first thing you need to know. And then we should know that for 1, 2, 3, so their squares only have one digit. And from 4 to 31, their squares, oh no. From 4 to 9, their square has 2 digits. And from 10 to 31, their squares have 3 digits. And from 32 to 35, their squares has 4 digits. So I hope you guys can check them one by one, right? So check the squares from 1 to 35. So, or it's recommended to memorize those square numbers, those perfect square numbers. So after having this conclusion, you can easily calculate the number of digits in this case. All right, guys. So this is the class today, and see you next time. And so sorry about the 4 extra minutes.
Bye. Thank you.
You're
Bye.
welcome. Bye-bye.
Thank you. Bye.
Bye.
Bye-bye.
Bye.
Bye.
Bye.